welcome everyone to the webinar with is a Data Readiness Cluster. And today we have the fortune to have Kasia Chmielinski joining us presenting on the topic of responsible AI. Kasia is the co-founder of the Data Nutrition Project, an initiative that builds tools to mitigate bias in artificial intelligence, and a fellow at Stanford University focused on building responsible data systems. They have held positions at the United Nations Office of Coordinated Humanitarian Affairs, U.S. Digital Service, MIT Media Lab, McKinsey & Company, and Google. They are also a purveyor of multimedia stories, and their work has been supported by organizations including the Rockefeller Foundation, Sundance Institute, Vision Maker Media, and NPR. With that, I'm going to turn the floor to you, Kasia. Go ahead.
Great. Just checking you can hear me okay.
Yes.
It's really lovely to see all of your icons. Thanks for joining so late in the day, so late in the week. I'm going to talk a little bit today about the Data Nutrition Project and transparency and kind of responsible AI and data. I do have some slides. I am very informal in my speaking cadence and process. So if you do have questions, please feel free to just jump in. I might not see your hand raised because I think once I share my screen, I can't necessarily see that. So do feel free to just come off mute and interrupt me and jump in and we can have a discussion at any point. I'll try to get through all the slides and then we can actually have a conversation. That's usually the most interesting part, at least for me. And I will go ahead and switch over to my slides now. All right, so I hope you can see my screen. Jump in if you are unable to. And again, I'm going to talk a little bit about applied transparency and what I'm seeing that the use of that as a mechanism for responsible AI. I think that there's a lot of conversation right now in the ecosystem about the principles of responsible AI, the principles of ethical AI, and a lot of my work now as someone who is advising organizations on building AI systems and data systems is to think about this in an applied way, which I think is sometimes a little bit more tricky than talking about it at the principles level only. So just to get started, my background, like I said, I'm a technologist. I'm currently focused on building responsible data systems. I've worked in a number of different places, and I'll talk a little bit about that. I'm also an incredibly enthusiastic cyclist and a bird watcher. So if you have questions along those lines, also very happy to veer into that territory. My background is actually, I studied physics many years ago. And after that, realized that I was quite unable to tell a story and didn't quite understand why the things that I wanted to do were not landing correctly in various rooms. And so I decided to go and join Google as a comms person, which I think is one of the stranger moves. Now that I'm older, I can see that that's a very strange move. And I give credit to Google for hiring me and to myself for going from being in an introverted kind of a room into the most extroverted and loud group of people that I could have ever found, actually. But it was an amazing opportunity, and I learned so much about building product. And actually, one of the biggest things I realized is that you cannot explain away a bad product with a good story. No matter how good the story is, you really need to have a better product. And at Google, I encountered many products, some of which were amazing, some of which were strange ideas that never made it out. And I decided at that organization, I worked in London for several years, that I actually wanted to move into product instead of being just talking about things. I wanted to actually go back into a more technical role and try to build these things right. And so after that, I've really been a product manager in industry, building systems, mostly big data, as we called it, in the 2010s. And I was at a fintech company called Zest AI. I founded that company with some folks, some other ex-Google people, ended up at the MIT Media Lab running a product called Scratch, which is a kid's coding language, and then went into the government, worked in the White House on many failing technology projects, as the U.S. Digital Service does, is kind of a tour of duty model. You go and you get deployed to government technology projects that are not working so well. You try to identify ways that these legacy systems could run more efficiently and productively. And ultimately at McKinsey in healthcare, where I worked on a lot of COVID analytics. So very familiar with data systems at that level in healthcare at this point. But you know, as my introduction also mentioned, I've told a lot of stories. I've produced some films. I've done some work in podcasting, and I also run this organization called the Data Nutrition Project, which is a dataset standards organization that came out of MIT Media Lab and Harvard. So now I mostly advise organizations. I've left the 9 to 5 PM world. I think that, what I've identified and realized is that having this kind of a background across domains, thinking about systems, thinking about it from the academic perspective, but then really at the applied level is very useful right now, especially in this age of kind of big data and generative AI and AI systems, and also responsible AI. What do all these things mean? And so now I'm advising organizations, everything from Mozilla AI, which is a small startup inside of Mozilla, to larger bureaucratic organizations like the UN, 2 different groups there, and others. So this is my kind of nonlinear, my strange nonlinear path. And like I said, my focus these days is really around, what are our responsibility as people who are building these systems? When I talk about AI, I think this is actually kind of a meaningless term, and I feel like you all are practitioners, so perhaps you share this. It's now become this umbrella term that's not specific enough to be particularly useful. And so when I say AI, what I mean is a simulation of human intelligence by machines that are programmed by humans, at least at this point, to perform complex cognitive functions. And that's a very large umbrella term. You know, the thing is that AI is really not new, even though there's a lot of hype today. That's me sitting at a desk when I was building things. When I started in 2010 at Zest AI, AI was coined as a term way back in the 50s. There's a number of growth points for AI over the last 70 years. And in case you need to have a little bit of scale for this, many other things in the world have happened over that time. So even though there's an enormous amount of focus right now on AI, it's not new, and additionally, our fears are also not new. You can kind of see pop culture, all the way since the 60s around machines that are coming to kill us. And even some of the headlines in the news look like headlines that we're seeing today. I swear that I kind of just saw some of these headlines, right? Will man-made robots rise up and demand their rights? Well, that was actually over 20 years ago. So a lot of what we're seeing right now is actually not new. It's a continuation of a story and a narrative that we've been seeing over the last 70 years. But as you know, AI is getting more powerful and more quickly due to 3 different factors. The first is compute power, just the amount of compute that it takes to run these large algorithms. The second is the availability of data. And this is kind of, I think the last 3 years in this are projections, but you can see it's basically up and to the right. There's just so much data information that's created, captured, copied, and consumed. And third is advanced mathematics. Although, as you probably know, this kind of generative AI obsession right now is not actually an advance in mathematics. This has been around for a while. It's really the other two, the compute and the data, that's enabling the advances that we're seeing right now in generative AI. And speaking of generative AI, I think that it is very much a focus right now and on everyone's minds. But to me, it's very reminiscent of the mobile app landscape. So if you remember back in the day when our phones were not smart, we could just SMS and we could call, and that was pretty much it. And then all of a sudden, there was a stack that was available to developers to build on top of. And that's when you really saw, on top of the hardware and the cloud, you saw these app platforms begin to emerge. So you had the Google Play Store, you had the Apple App Store, and then on top of that, you had all these applications. And there was really this amazing explosion of consumer-focused applications and games and things that suddenly emerged. And that's pretty much what we're about to see in the generative AI landscape. So now we have, compute and cloud available to us, which we've had for quite some time, but becoming more and more affordable and available. And these foundation models, and there's currently a very large fight happening between a small number of actors trying to grab for this space to be able to put in production models, either open or closed, that really will become the basis for a number of applications that sit on top of the foundation models. And that's what we're about to see, is this kind of explosion of user-facing applications, such as Copilot if you're in the coding space, or Sora, AlphaCode, Scribe, ChatGPT, I think is the most commonly used one today. But this is going to be just one of many, many, many applications that we're going to see. And so you might say, well, what does that actually look like? And this is an a video that was created by Sora, which is, again, this application that OpenAI built on top of its own foundation models. They gave it the prompt here, several giant woolly mammoths approaching, treading through a snowy meadow, etc. You can read it. And without any human intervention, this is what was generated by the machine. So you might think, oh, that's pretty cool. It looks very high fidelity. We've never really seen a woolly mammoth actually alive like this. So we've had renditions, obviously. We've seen skeletons, but we don't really know what they look like. And here we go. This machine is making all of this. How cool. I guess to bring it home a little bit more, the kinds of thing that this might enable, let's say that you watch a TV show and you get to the last episode, the last season, and it just doesn't go your way, right? The plot just twists in a direction that you don't like. You will be able to very soon go to something like Sora and say, redo the last episode, but change the following plot points. And you can just make your own new ending to the TV program, right? And I think that these are the kinds of things that are going to become fairly commonplace for good and maybe for more nefarious or malicious applications quite soon. Get past this here. So to recap, AI is not new, right? Though it is increasingly powerful and it's growing rapidly. And it's not just, it's not just about what we're building, but also how we're doing it. So to kind of veer a little bit into the territory of, what it is that, or the way by which we're actually building these tools, products are market driven, which means that we are optimizing for the growth of those products. I started a company with some folks, this kind of fintech company. And so I can tell you that the pressures are real when your investors say that you need to grow by X% or X amount by the next time that we have a board meeting. If you don't manage to hit those numbers or have a very good story as to why you didn't hit them, you won't get more funding and your product will die. So when everything is market driven like this, it means that you're kind of laser focused on those growth metrics. And that means that you're really building for kind of the middle of the bell curve or one kind of user, the majority user, often at the expense of other users, right? So you're building for the middle of this bell curve here, and then you're adding additional identities over time. So for example, I might be building for this 80% majority, let's say, and that means I'm going to cut out folks who don't have a binary gender, people who are sharing technology, who don't speak English, who don't have the most recent tech, right? People who live in places that don't have high connectivity. And so that means that we're not really building for everyone. But frustratingly, a lot of the focus or the hype really right now is on existential future risks rather than the actual risks. So these are the kinds of headlines that we're seeing that, there's some kind of profound risk to society, that we should be fearing AI. And I'm not saying that there's a 0% chance that the existential risks are going to come true. I mean, obviously, AI is very powerful. We don't know exactly how it's gonna go. But I would say that the more pressing and immediate harm or risk that we see is the consolidation of power and control in the hands of the few. And this is the graph that I like to show because I think it really illustrates what we're seeing in the market. And this is actually, research teams that are building notable AI systems globally. And you can see over time, there's more teams that are building AI systems because AI, of course, has emerged and grown over the years. But then there are a few things that have happened in the last 5 years. One is overall fewer teams. So there's just a consolidation in the market because we know there's still AI being built, right? It's not that there isn't AI being built. And then the other that you see here is the elimination or the reduction in the amount of teams that are based in academia, which is this blue line. All of a sudden, all of the academics are basically going into industry. So you're having this consolidation of the teams and the AI and the output into a proprietary ecosystem of industry focus, right? And that is pretty dangerous when you think about the how ubiquitous and how pervasive this technology will become and how it is going to be the foundation of all these consumer applications that will sit on top. And so this, I think, is the real risk. So to recap, this is kind of what folks want you to think is the problem, like AI is coming to eat our lunch. But this is the actual issue, which is, hey, like the folks who are doing the sketchy stuff are like doing even more sketchy stuff to get even richer, and nobody seems to care. And so that's kind of where I'm coming at this conversation is as a practitioner who's building these systems and seeing these systems get built and understanding that it's growing faster, that the systems are becoming more powerful more quickly, and that it's consolidating into the hands of the few. And it's kind of the same names that have been on the masthead for quite some time. So the real risks are products that fail communities at scale and that are further consolidating power in the hands of the few. So this kind of brings me to some of the work that I've been doing that I think is more applied. In 2017, I got a fellowship at the MIT Media Lab and Berkman Klein Center at Harvard University with a bunch of other super smart people. And we were asked to think about the ethics and the governance of AI. And what we saw at that time, these are some of the headlines in the news from around that time, was that AI was causing a number of issues, and these issues were maybe, let's say, unfairly or kind of unrepresentatively falling on the shoulders of folks from communities that were already marginalized. And so, the social problem that we saw here actually ended up being a data problem, right? So when you have data sets that are unrepresentative, they end up causing the same problems as the issues that are in the underlying data. Not to mention, there's just kind of a lack of data set quality standards and tools to catch many of these issues. So, I'm sure you're familiar with these, but maybe I can dive into one or two of them. For example, this on the right-hand side, Amazon creating a hiring tool. Well, they built the hiring tool, the AI tool, that was supposed to scan resumes and give some kind of a score or recommendation for whether or not this person should be interviewed or hired. They built this AI on historic resumes. And historic resumes are biased. So over time, if you look at the number of people who are offered interviews, who are offered jobs, there is a human bias against certain genders, against certain races. And when Amazon then created this AI that was built on this historic data, it immediately started to discriminate in the same exact way that there was discrimination previously. And so this was a situation in which, because the underlying data set had a bias issue, that ended up kind of seeping into the predictions and the recommendations made by the AI. So, when we think about this being a data problem, this kind of problem in AI, this bias and fairness issue in AI actually being an issue of bias and unfairness in data, it's further exacerbated by the fact that there really isn't a standard tool or a standard approach to identifying bias in the data. You have custom tools, kind of like domain-specific languages for looking at data sets. You have custom formats of documentation, custom formats of data itself. And then even when you have really good documentation, sometimes it has a poor user experience. We worked with this, Department of Education. We were talking to them about their college scorecard data set, which is this, pretty amazing and powerful data set. And they really wanted to do the right thing. Maybe some of you even worked on this. It's a really a phenomenal project. And the documentation itself was 55 pages in a PDF. And I just know, as somebody who's from industry, if I was on deadline to select or integrate a data set for, next Tuesday, I'm probably not going to read all 55 pages. So you can have all the most amazing information actually documented, but it's in a non-standard way about a data set that isn't, has its own kind of process. And also it's hard to read the documentation. I'm not exactly sure what I'm looking for when I look at it. So when I was in this fellowship with folks, we kind of were puzzling over what's the kind of intervention that we could make in the space that would be meaningful. And what we saw, like I said, is that systems that are built on problematic data will exhibit the same issues, especially for historically marginalized people. And when we think about this AI model pipeline, you start with the data set, you pre-process the data, you develop the model, you deploy the model, and then that model is deployed on the world and changes the data set and changes the world. And there's this kind of cycle that's happening there. Well, what we thought was, well, shouldn't we be interrogating issues in the data set before we build? And what we kept seeing, like in those news articles, is that people are interrogating for bias after deployment. And the thing is, if you've ever built an AI model or some kind of a machine learning model, or really any advanced statistical system, you know that by the time you get to deployment, you've put so much work in that it's actually quite expensive to go back and do it again. At that point, you'd have to go all the way back to the data set and maybe clean the data or modify the data set or reprocess it or something. And by then, especially if you've been at one of these companies, you've gone through, dozens of people, maybe millions of dollars. And it's quite expensive at that point to identify errors and go back to the beginning. And so we thought, well, we're sitting here in this room, eating a box of cookies. We're at MIT and we're drinking lots of coffee, and we're thinking, there's a nutrition label on this box of cookies, and it allows us to see inside of the cookies before we eat them, right? So we can actually interrogate, hey, is this healthy for our bodies, for our use case? And this highlighted to us the importance of transparency for choice, right? So what we can do is, maybe we can't force the system to be any better, or force the data to be any better, but at least through disclosure and transparency, we can kind of drive better choice. So I can say, okay, there are 4 different data sets I could use. I could compare their nutrition labels, and then maybe I could choose the best one for my use case. And so that's what we decided to use as an analogy. What would it look like to build a nutrition label for a data set? Um, I should pause to mention that there are many folks in this kind of documentation space. We're not the only ones. And we really came of age around the same time. It's a very exciting time in 2018. And a lot of these interventions are happening at different points in the life cycle, in the AI life cycle. So you have what we're working on, and also something called data sheets for data sets. We use a lot of the same underlying knowledge structure, in fact, and we are quite good friends with those teams. And we're all looking at the data level. So we're saying at the point of data collection, and then the data selection and usage, what kinds of information can you provide somebody so they can make better choices? You've got model cards, which are transparency mechanisms at the model stage. You've got the IBM fact sheets project that is more around runtime. So they're kind of telling you how the model is actually doing. And they kind of cover a lot of this actually through it, but they also follow through to the deployment. And you also have data statements, which is kind of on the NLP side. So there are many groups working on this. We're not the only ones. And we think that depending on your need, might want to use one project over another, or many in tandem. So in terms of what we actually managed to create, we had our first version in 2018 or 19. I'm really bad at the numbers. And it was very quantitative. We wanted it to also kind of look like a nutrition label for food. And we launched with this. It kind of programmatically would look at the data set and show you distributions and things like that. In addition to gather some information that was kind of metadata about the data set. And we actually got feedback that it was not so useful, because if you are a data scientist or somebody who's a practitioner, you're probably going to run those kinds of things yourself. This is the kind of exploratory data analysis that you would do anyway. Based on training in the field. Even if there aren't standards, there's kind of like norms around what you'd do. So our second version, which came out a few years after that, in 2020, was much more focused on being opinionated about potential biases. And so you can see we have these alert counts by category, by race and by gender, and these types of things. And although that was, we heard from folks, fairly useful if you're trying to select and use a data set, no data set owners wanted to work with us, because we were basically in the business of saying everything that's wrong about someone's data set. And people don't want that, especially practitioners who have spent so much time curating this data. There is no perfect data set, and we know that. And so almost by definition, we're creating something that is just quite negative, and folks don't want to affix a negative voluntary label on their data set. Why would they if they don't have to? And so we learned from that version, and our most recent version, which we like very much, and I'll tell you a bit about, is kind of a combination of the two. And what we have on this new version is kind of a qualitative/quantitative approach that standardizes the UX, so the experience of reading this label. There's the kind of meta label on top, which tells you how complete the label is itself. It's kind of like the meta label, tells you who created it and when it was published and updated. And then the actual label itself includes this panel here that says how do you use it. So this is about intention, intended use, known uses, known risks and things like that. There are your normal kind of metadata components. And actually I can kind of show you some additional information here, such as at-a-glance information about the key critical aspects of the data set, so that if you have 10 seconds, you can learn something. If you have 10 minutes, you can learn a lot more. And obviously, if you had 10 hours, you could really dig into everything about this label. We want it to be fairly easy for someone to come to this and immediately understand something, and be able to make better choices. So we've got these badges at the top, which are things like, is this about humans? Has this been reviewed for technical quality, as well as going through some kind of an ethical review? Is this dependent on any upstream sources? And also that kind of how to use panel, which shows you things like what it was intended for, how it has been used, and any warnings about how it should not be used, and any restrictions such as licensing or copyright or these types of things. One thing that we found in working with dataset owners is that we really, primarily built the label to improve the consumption of data. But as our dataset partner here mentioned, it actually changed the way that she designed her datasets going forward. Right. So not only is it changing how people are actually able to understand what's inside a data set and make choices, but it's also changing how folks are constructing, collecting their data to begin with, curating their data and putting it out there. And so we think this is a pretty subtle but important outcome of having something like a nutrition label. I guess the analogy here would be, if at the end of making your cookies, you're going to have to tell everybody what's inside, you might make different choices about what you put in your cookies, because you know that at the end you're going to have to say, what the ingredients are, and so if there's something shady in there, you will eventually be held accountable. So here you have transparency as a form of accountability. I think I'm getting towards the end here. I want to make sure there's time for you all to ask me questions if you have them. DNP is in a lot of conversations with many folks in the ecosystem. And we kind of see these conversations along a number of different lines. We talk to organizations about their data practices. As you know, a lot of places already have metadata standards, and they already have data collection processes. And so a good example is the UN, OCHA, where we actually engaged in a kind of a sprint with them to look at the data quality assessments that they had already and tried to suggest a number of improvements, which they've since started to implement around how they could actually consider quality and make that a standard in a way that would be useful for the humanitarian sector. And we've talked to other folks about their metadata standards. In some cases, folks have actually built our rubric into things like certifications, or it's just a standalone standard that is, for example, at NeurIPS, you can actually submit your data set and have a label attached to that, and that's seen as documentation, just like any other kind of documentation. Finally, something that we also have recognized that we didn't really expect is that using the label as a way to teach data quality or teach about data quality has been really impactful and pretty successful. So because of our historic ties, our kind of initial ties to academia coming out of Harvard and MIT, we've brought our work into the classroom at Harvard and also around the world. So this is a picture of a workshop that we did with students at the Johannes Kepler University in Austria. And through using the label, we have an open tool, basically. You can go to our website and use it. And through using that tool, we teach students and others, professionals as well, about what it means to collect data and how to think about data collection in the process of collecting that data. So again, using the documentation almost as a framework to teach people about data quality and the kinds of decisions that they might need to make along the way. So that's a very brief overview of kind of where things sit in terms of the field, the kind of actual risks and harms that might come from AI, much of which is due to underlying data, and some of the more practical implementations, such as the nutrition label that at least I've been working on and that others in the field have been working on as well. Thanks. I'm really happy to take any questions.
Right. Thanks, Kasia. I see one question in the chat. Joda, do you want to go ahead, unmute and ask your question?
Hello, Kasia. That was great. That was very informative. I got a lot out of that, and I'm really glad I joined. I'm the chair of the Geoscience Remote Sensing Society Standards Committee, and we deal with remote sensing sensors and products. So it's I'm not. It's outside of my wheelhouse, but I'm very interested nonetheless because of other applications of AI in geosciences. My question was, so we've heard about because one of the limitations, with AI is not having enough data to train on. So there's been this push to synthesize data based on existing data. I don't really how it works. I've only heard about it. How I suppose that's also would be prone to propagating biases, but could there be some correction incorporated in generating synthesized training data?
Yeah, it's a great question. I think synthetic data is definitely, I wouldn't say, I mean, it already has emerged, so I wouldn't say that it's emerging, but I think that the momentum behind synthetic data is certainly growing as a way to address some of the harms in data. So I think that when applied with positive intent and kind of, in a careful way, synthetic data can actually help address a lot of the harms, but it might also create additional harms, right? So it has to, just like anything, I think people have to really consider like what they're trying to do when they build synthetic data. I can give an example. So, for example, I worked on a lot of COVID data, especially around vaccines. And the data that we received from, I was mostly in the US, the data we received from the states and from the federal level was about 30% complete when it came to demographic data. But everybody really was clamoring at the time, understandably, for equity data. So are we reaching all populations with a vaccine at the same level? And can we use this data and demographic data to identify communities where we might need to do greater outreach, whether it's the elderly, people high risk, people in certain communities or certain geographies? And we actually didn't have a lot of demographic data. And so what you end up doing is you end up imputing information for 70% of that data and then making determinations, right? So in that case, synthetic data is really the only way to go because we need to fill it in and make decisions. That's like within a data set. I think there's also a phenomenon where you're trying to train something, you just don't have enough data. And so you're using a data set as seed data, and then you're building based on patterns in that data, you're building a bunch of synthetic data, maybe holding some things more fixed and varying others so that you can have the kind of representation that you're seeking at a larger scale. The issue there, so you can avoid issues of, let's say, personal identification, right? So you've anonymized the data or something. You could still possibly de-anonymize that data and identify people in the original seed data set. But if you take that seed data set and you explode it out and copy the patterns you need, but then remove the personal identifiers, that actually really addresses the issue of personal harms that might come from the data. But what it doesn't do is address the issue of community harms, because what you're doing is you're taking the seed data set and any kind of patterns that you might see, fair or unfair, about certain communities, and you're just perpetuating that. So I think that synthetic data ends up being very helpful to address some things. And in some cases, it's the only way, right? You either have to impute something or you have to make decisions so that you can actually go out there and do the things you need to do in the world, knowing that it's not perfect, but it might be better than nothing. So there are real reasons to use synthetic data that I think are very compelling and that people are doing anyway. So it doesn't matter if I think it's compelling. But then I think there are real issues that do arise because some things just are not going to go away just because you're making synthetic data. In terms of how this applies to transparency of the label, I think it's really important, first of all, that we just understand what these systems are built on. And so having some form of, right now, if you build AI and you deploy it, there's no requirement that you disclose how you trained that. So ChatGPT is out there, GPT is out there, and we don't know what the underlying data set was. And that means that we don't even know what harms to look for at scale because we literally don't know how they trained it. This can be even more concerning in, let's say, a medical AI application space, where you have medical AI that's being built, let's say, to treat a certain population. You have no requirement. There's no requirement that the AI, the black box AI developer, tells you how they trained that AI. So you don't know, is that underlying population that you trained it on, does it look like me? Right. So I think we need to have transparency. And part of that would be to disclose, is this a synthetic data set? What was it seeded on? Why did you do that? Right. And I don't think we should treat synthetic data sets any differently from any others when it comes to documentation and transparency into it. It's just a different kind of data set. I hope I answered your question there. I have a lot of feelings about synthetic data, clearly.
Right. Thanks. We have another hand raised. Yes, go ahead.
Hi, yeah, really, really good points. And I will raise another one, which is that sometimes you have data where it can only be synthetic, like climate change data, we don't have observations of the future. So all of our data about future climate that people might want to use, and people want to use a lot of it, is from models. And one of the things I wanted to ask about is there any way to flag one of the big things that I see, which is this is synthetic data. Everybody knows it's synthetic data, but that means that it differs from the real world in a couple ways, and maybe ways that you aren't even aware could be different. That's one of the things that I keep wanting to wave red flags about is communicating to people things like, oh, by the way, not just that this climate simulation is based on certain assumptions about future human behavior, but oh, by the way, leap years don't exist in this data. And if people aren't aware of that, they can, do things where they apply the data in a way where they don't realize that it's differing from the world in this way. And all of a sudden they've got something where, when they get out 100 years, their data is off by 3 months, which really screws up your statistics in a weird and subtle way that you can have difficulty realizing is even happening if you're not a specialist.
That's such a great point. And there's kind of two things that I would tease out from that, right? So the first is just like communicating limitations.
Yeah.
That's so important. And I have like a million questions for you about other limitations of this data. There's going to be limitations, I think, of almost every data set that you find. I mean, even if we had a one-to-one representation of the world itself is biased, right? So I think there's kind of, yes, there's the limitations that we have to call out. When it comes to the label or any kind of transparency mechanism, we've had to walk this fine line between being domain specific and being general. And so like the more general application or generic application would be list your limitations, but maybe there's also a specific label or specific questions or call outs for climate data because there are common things that need to be called out. And so I think there's an interesting tension there about how specific do you get, how domain specific do you want your standards to be? And often they are quite specific because it's a domain, so it makes sense to do that. And I think that's one of these things that still needs to be teased out. And the second thing that I would call out is something that you kind of mentioned in passing, which is the importance of subject matter expertise and in including people who are domain experts when it comes to reviewing and deciding to use or how to use or how not to use the data. And that's something that we've really been focusing on at DNP, the Data Nutrition Project, which is the 501c3 that built around the label, is how do we assess the labels that people submit to us for our public repository? How do we actually assess those in a domain-specific way? Because I'm not an expert on climate data, but I might receive a submission of a label for a climate data set. And how do I then certify that that's correct or not correct if I don't have expertise in that area? And so I think something that you're pointing out is something that might be very obvious to you as a climate scientist or someone who is familiar with that data might be really bizarre to somebody outside. They would never even think of it that way because they don't have that expertise. And so how do we make sure that the right people are in the room when we're making determinations about things like which data to use and how to use it? Really great points, though.
Yeah, thank you.
Thanks, Kasia. We have two more hands. Raina, go ahead. You'll be the first one.
Thank you. Yeah, this has been really a great talk. And one thing I'm doing is I'm also poking around the data nutrition label website at the same time, trying to figure it out exactly kind of how it works. And I've made an account and I'm not quite understanding the process of creating a label. And I've downloaded these questions. And so I was wondering if you can just describe the process a little bit more about like how from a given data set you get to the point of having the labels. And are these questions sort of the basis for then sort of these standardized labels that you have? If you could just like maybe walk through the process of what happens and how a data set is analyzed or I guess analyzed by the person bringing it forward.
Here, let me just share my screen. So I went to labelmaker.datanutrition.org and I'm already, I think, signed in because I like kind of live on this site, so that's fine. But here we go, log in. Here we go, I log in here. This is the dashboard where I've, there's many to reviews. We're very much in like a prototype phase. So these are all of the these are all the labels that have been submitted recently. If I just opened one up, you could actually open it up and take a look. I actually don't know what this is. So this is poverty and water toxicity in America in 2017. You can see it says draft across the top because it hasn't been reviewed. And this is, to be just fully transparent, this is something that we're trying to figure out as a group, is how would we actually review this label and determine whether or not it is it's correct. And that's really tough. And we're starting to build out panels of experts that we can kind of tap and hopefully also pay for their time to go through and make sure that what's in the label is relevant and accurate to the best of our ability. But if I were to look at this, here's the description. Again, I've never seen this before, so I have no idea what this is. This is fairly complete in terms of the questions that were filled in. And you can see this person has said that, who they are, and they're not telling us how they're related to the data set. I assume it's probably not theirs because they're saying, I don't know, I don't know what the restrictions are, right? So we'd have to go and talk to this person and say, can we figure some of this stuff out, please? Here are the intended domains. Here are the ways that it's used right now, and a link so you can actually learn how it's used. And here they're saying, I don't really know. And so, there has to be a back and forth where we actually go through and say, can we figure out together what the answers are? So here are some risks that are associated with the data set. And the way that this works, so this would be me as a reviewer taking a look at this. And then if it goes through the whole process, we take off the watermark. If I go forward and I actually try to create one, this might be very boring for all of you, so I'll try to do it quickly. I can actually go in here. I can create the label, say test label. Sorry, Matt, that's our backend guy. Why are you making it? Test label, sorry, Matt. And it's a series of questions essentially. And so you answer these questions about the data set, and these actually align pretty well to data sheets for data sets. We've tried to keep this, and also data statements. We've tried to keep this fairly similar to a lot of the other structures that are out there. The difference is, of course, that when you finish this up and you actually submit this, or you save and exit it, you get a draft that is visualized, and there's a live link to this, and you can update this over time. And so you start to gather kind of a repository of live labels that can be updated, and that there's a way to understand them across every label. They kind of look and feel quite similar, so it's easier to identify the information if you're comparing multiple of them. The other thing that we're working on as a team is how to quickly compare data sets, because now all of this is in a giant JSON blob, which actually I believe you can just download. You can actually I have to figure out how, once you submit it, actually, you're able to download the JSON blob so you can have your data. Obviously, it's yours. Since it's in this structured way, we can now start to compare things to each other, which is, one of the powers of having a standard. And we could actually either programmatically or at least visually allow you to compare multiple data sets along multiple axes so you can choose the one that's best for you. So hopefully that explains it. That's kind of where we are right now. It's very much, kind of a prototype that's actually out there in a tool that can be used. And people have been, clearly they've been using it. Yeah, and I don't really know how all of them are using it, to be honest. That's the joy of making a product.
Thanks, Kasia.
Yeah, that was really helpful. Thank you.
Sure. If you have more questions, feel free to email me. I'm happy to kind of point you to more, tips and tricks and all these kinds of things.
Right. I see Eric has the hands up. I also predicted what Eric is going to ask about his question. So I'm going to put the prediction on the side and see if that's the same question that Eric wants to ask. Eric, go ahead. You're muted.
How's that? Did that work?
Yes, good. Yep.
All right. Well, we'll see what the question matches Douglas's Nostradamus-like skills here. But my question actually is, so I'm the owner of a very large data archive, and it's interesting to put together data labels for an archive specifically around biases that might be in the data, appropriate uses, that sort of thing. But the way we usually do that is by it runs into a model, and then we see, oops, it's not performing in this area. For the example you gave for Amazon, it wasn't, the data sets are so big and so vast that a human looking at them wouldn't notice, oh, wait a minute, we're not representing women or other communities here. Or in my case, some element of, geospace is being undersampled, and then we see it through the models. What is the typical way that it is investigated? Is it community reports back after it's been run into modeling, or guesses from the PI? I know some of the things that are in the label are, how it was collected and what we call standard metadata, but how do you get to that? How do you typically identify that bias?
That's a great question. I mean, I think that when we were initially designing this, I think today the massive data sets are more prevalent than they were when we were initially thinking about this. Of course, there were massive data sets, but today, like a lot of what we're doing is driven now in terms of AI by massive data sets that are very hard to investigate, or impossible to spot check. I mean, you could spot check them, but you can't investigate them entirely by hand or by eye. And not to mention they're streaming, so they're changing every day. So how are you gonna, assess that over time? So what we have built is really more this kind of qualitative metadata. And when we are talking to PIs who are representing the data set, they are then representing the results of the models that they've run and the kinds of issues that they've identified. So there's obvious limitation there because we're using the knowledge base of the PI or someone who's very familiar as a proxy for the truth. And that's really tough. I think it kind of comes to the question that we had before about domain specificity. And I could see a way in which, and we've worked with some folks who are kind of doing this with the label, they're taking what we've built and adapting it to their domain, and then maybe adding a few questions about benchmarks. So if there are models or there are benchmarks that are applicable to that particular domain, like let's say in the humanitarian sector, completeness of the data set based on some underlying ground truth. Are you covering all the counties? Do you have all the P codes, the place codes, and kind of standard assessments that you might run on humanitarian data sets because in that domain that is important. You can they're adding that to their own metadata, which uses some of what we've done. They're then adding a bunch of other things that are more programmatic, that are maybe more quantitative, that then could, it's like a modified label, basically. It's like a label plus plus. And so we haven't been so precious about someone using our label specifically. What we're more interested in is emerging standards that ask some of these questions that kind of prod in this way. And like you said, you run an archive, you already have a metadata standard. It would probably not be smart to just like get rid of your whole metadata standard and try to have another one. I mean, that's not the reality, I think, of a lot of data repositories and dataverses that are out there. But what you could do is say, hey, from the nutrition label, what are the components that we don't have? Maybe it's about intended use. Maybe it's about communities involved in collection. Maybe it's some of the processing questions, right? And why don't we now add those to our metadata and kind of enhance what we do, so that we can kind of borrow from here and there. So that's mostly how we've thought about this. And because again, if we required that everybody follow the benchmark for geospatial data, how's it going to apply when we get a data set about population, like a census data set? It doesn't apply, right? It's domain specific. We're trying to keep this at fairly generic level. I hope that answers the question. I'd also love to hear from you, like what you do, I guess, in order to kind of have something comparable across your archive when it comes to metadata.
Yeah, I mean, from our community, the tradition has been that feedback with the community. Hey, we used it in modeling for this, and it's we're missing this part of it. It's not representing this domain very well, that sort of thing. And then we feed that back and capture it in the metadata. The problem is with these big models, as you mentioned, it's millions of dollars down the road. You've developed a model off the top of it, and then you have to come back and say, oops, now we helped you find your biases. So it's really interesting to think about what can we do better to document, identify that stuff up front so that we're not leading people down a bad path.
Right.
Thanks.
Sure.
Right. I think I'm just putting the link to what this group have worked on in the past, which is something we call AI ready data checklists, which have different components, including one thing as the data quality specifically, right? That as you have probably figured out, this is a group of people mostly focused on geospatial and space data. And so right now we don't really have a standards for the quality information to be documented in a way that can be easily turned into something like a label, right? That you may have a 50 pages documentation assessing the data sets, and then how you distill the information into a way that can be easily like you showing with the labels make it easy for people to consume those information. That's one thing we have been thinking about. The other thing is that, like Eric mentioned, for those data archives, a lot of times, if you want to go through all the data set, then you really need a process that can help you streamline process, right? Right now, you're showing the pilot as a way, as like human in the loop of entering a lot of those information. But how is there any way, like you mentioned about this metadata standards, and then incorporating some of the information from the metadata standards to be part of the creation like process for the labels? That would be super interesting development as well.
Yeah, and something that also we've seen is, using the label process, so that label maker, with those panes of questions, right? And we've got those different kind of that little navigator on the left that will take you to different parts. Using that label maker to fill in the information while you are curating the data set is actually a great way to shift the process of building the data at all, right? So it's like the documentation, the label ends up being an output, but that's maybe almost like a chance output that happens at the end of it. It's almost like you use these questions as a guide for things that you should think about when you're curating the data set. Like a checklist of, oh, hold on, like who am I including in this, and who did fund this, and how am I going to maintain it, and what's my update schedule, and where's a link where it's going to live, and all these kinds of things. And so you end up with the documentation at the end, which is just like a happy outcome. But what you've done is actually shape your process and made it more diligent just by following that path as you're building the data set. So it's a very different process when you're talking about a brand new data set that you're creating versus trying to document something that's been out there forever. Right? Some of these data sets that are legacy data sets, or they're time series data sets or something like that, they've been around for 40 years. Like, kind of hard. I mean, maybe no one knows exactly how it started. I mean, it's so long ago, right? And so I think that the challenge with standards, I don't have to tell you all if you've been building one, is that there's a lot of different kinds of data. There's a lot of different domains. There's a lot of different complexities. And so probably it's about taking what works from this and applying it to your own fields, and then modifying it and making some combination of quantitative and qualitative output that then becomes a standardized documentation.
Right. Thanks. Yeah, I'm so glad that we have you today, because a lot of the discussions or the consideration you are talking about with the DNP is something we have talked about in our own group, thinking about how generic the checklist we want to build are, or like how specific you want to go to. Because even within geospatial data, there are quite a diverse type of data. I see Rob turn on video. I assume you have questions. Go ahead.
Yeah, you like unface muted, so I think that's the same thing as raising a hand.
I was afraid to do that. I'm trying to think of, first of all, thank you so much for coming, and I realize we're probably out of time, so I'll just be respectful of that. I was trying to think of a great, I love this work, and I work with Douglas and Eric, and I was trying to think of a witty question, and I can't. So what I wanted to ask, what I wanted to suggest or ask is, you told a great story about someone had a data set, then used this label maker to help inform future versions of their data set. I think if I heard that correct. Do you have stories now, or we'd love to hear when you do, if not yet, on data that lived out there and got labeled, and people were benign in their creation and everything, but the act of labeling ended up producing a better and even more useful product? I don't know if I didn't hear if you'd shared one of those already. I apologize. Otherwise, I'd love to hear when you've got this.
I mean, so we were working with Memorial Sloan Kettering, which is a cancer center in New York, and they are very focused. They're working with a dermatologist from MSK who's very focused on this skin challenge, this melanoma challenge that's on Kaggle. I don't know if you're familiar with Kaggle. It's like a machine learning platform. Okay, so you can kind of crowdsource solutions. People get paid. Yeah. I hear that it's lovely. And so every year they have this this challenge where they put a data set up and then they ask folks to predict a melanoma, and then they use that algorithm to basically build like virtual dermatologists that then they can deploy on a mobile app or something like that and start to push that because there aren't enough dermatologists in the world. So we worked with them to build a label for one of their existing data sets. And in the process, we asked about representation. And it kind of came to the fore that, not surprisingly, there's not really an even distribution of skin colors and skin types in this data set. And they became so kind of obsessed with this, especially one doctor in particular, that she really changed like almost her entire career to now focus on how do we build representative data sets. And so the thing is that they do this every year. And so they're building the next data set. And so the next data set, they were really focused on, hey, can we get better representation? And every subsequent year, they're changing kind of, hey, can we really focus on this? Because we also notice in the algorithm, so to your point, to a previous point, they will then model on that. And then it turns out that the model doesn't do as well on certain skin colors. So they can see it also in the results. And so this is now something that they're very focused on as a group. So that's kind of an example. I mean, this is one anecdotal example, but it certainly changed that person's career. And then also, I think, the shape of that data set over time.
Okay, I Googled it. I'm on Kaggle now.
Cool. It's called ISIC. It's ISIC. It's the International Skin IC.
Yeah.
I don't know. Yeah.
Okay, thank you. I feel like I might have heard a piece of this story from somebody, but not in this like comprehensiveness, and never did I connect it to the project you're on. So, or that you're leading.
And I can't take full credit for it. I think that we're part of an emerging consciousness, right? That everyone is becoming on like, facial recognition algorithms and so like people are really aware of like skin color being underrepresented in certain ways in data sets. So I can't say this is entirely because of us, but certainly we saw it changing, right? Because we were working with them on the documentation and it suddenly became something that was quite important to them.
Well, thank you so much. Thanks for the sharing example.
Right.
Thanks for the prompt.
And I think that brings up a topic we were also thinking about, is how do you capture those use cases and as a way to demonstrate the impact of such work, right? That is one thing. I'm not sure. Have you thought about how do you capture those information?
I mean, it's truly an excellent question. I feel like, I mean, you all probably face this in your lives. My personal life, I say that I work on data and people just like lose interest, right? So I'm like, they're like, oh, hey, like, who are you? What do you do? And I'm like, well, I think about like the quality of data, and they're like, shoo, right? And they're just gone. So I think that there's definitely a storytelling element when you're talking about how do you kind of take these stories and get them to the right audience so people understand the power of this. And unfortunately, I mean, if you have the answer to this, please tell me. I'm working on some side projects around storytelling, around data. So I'm very open to pitches if you have, in particular, examples of terrible data sets that you think should die. I'm calling it zombie data sets, right? So like these data sets, like they should not be living, but they keep having a life. And we keep using them because it's the best one that we have, or historically we've just used this one. So a few examples of that, let me know. So number one, storytelling. But I think the second thing is like, unfortunately, what I see is it's way easier to understand the harms of data when it's the model that has a bad output. And that's why in the news, you're seeing basically models gone wrong, like the model's racist, the model's sexist. Yes. And the real story is probably the data. I mean, you can do some training things that are bad too. Absolutely. Like your feature selection could be bad and you could be overfitting to certain things or whatever. But like probably a lot of that's coming from underlying data, but that's like not a fun story to tell until there's some kind of an output that has harmed somebody where there's proof in that. I mean, fun story. That's not a story that's going to get any uptake. And so I'm actually very open to your thoughts around this too, because I don't know, I'm trying, but people don't want to talk about data often,
I think you are in the group that you're preaching to the choir that we are all data lovers. So, thank you so much for your time, Kasia.
Absolutely.
I know, it's great. And just want to get permission that we can share this recording, right?
Yeah, please. I mean, yes. And then I guess I can make an appeal and a pitch to folks that if you do think of really interesting data sets, especially in the geospatial world, please let me know. I'm all ears.
Great. Thanks. And thank you everyone for the engaging discussion.
Yeah, thank you all.